Hello. This is comparing patterns in React and Ember. I'm Preston Sego. Thanks for the introduction, MCs. Before we get started, you'll need to know some things about me. Mostly none of which are super relevant to the rest of this talk, but are very important to me. I'm Nullvox Populi, pretty much everywhere. So there I am. Thanks. I'm also the author of Emberclear. This is a side project. It's a chat app, or CHAP, if you're one for unnecessarily contracting. The QR code here will hook us up in a little private chat. This is my wife and me. She's my favorite human, so go her. I like ping pong, and StarCraft is the best game ever. I play Zerg. And this is where I do React, at Developer Town. I've been doing React for nearly 3 years, and Ember's just a hobby. I do not do Ember professionally, unless I do a side project for them that does a lot of arm and leg pulling. But anyway, so comparing patterns in React and Ember. At the highest of levels, there are ways in which each can be used to solve the exact same problems. But it's the implementation details that differ. Ember provides most functionality you need to build an app. React tends to need a lot of decisions around tooling and patterns and a bunch of other stuff in order to build anything of real worth. And as a disclaimer, I can only work with my own knowledge and what I'm able to learn, what is relevant to my job and side projects. If you know of any better way to do anything, please feel free to call me out on it, message me on Twitter, anything. Always happy to discuss things. Also, there's a lot of code in these slides, and I don't intend for it all to be read. I hope that at the end of this, everyone will be able to have better conversations with those in different ecosystems so that we can better learn from each other's experiences. Maybe these slides can be used as a reference. I don't know. All right, so React is just components. So in order to interact with anything, you have to reinvent a lot of architectural patterns that are already present in other frameworks. A lot of people enjoy this about React because it's initially much less cognitive load. Now, React does have some primitives for making some common tasks easier, but we'll get to that. Ember comes with some battle-tested abstractions for common architectural scenarios. The service layer is the main point of communication between Ember and long-lived state, such as those from Ember Data, Orbit, GraphQL, or Redux. React does have some parallels to each of these, though, so let's take a look at them. But first, a quick demo, so you'll have some reference for upcoming samples. And play. All right, so in case you haven't seen this before, this is the classic to-do MVC. There is that input at the top, the header of the list. It allows you to input your to-dos. There are other things that to-do MVC can do, but right now we'll just focus on the header. So to implement this, we need a way to manage state. Services in Ember are a good way to do that. This will manage the list of to-dos, provide helper functions, etc. Next, we'll inject the service and use it. Cool. That was easy. Our header component can now add to-dos. So now if we step on over to the React side of the universe, we'll idiomatically implement the same thing. First, we'll need to create a context with a default value. But wait, what's a context? Why are we doing this? So React is just components, which many people like due to the simplicity of only having to work with one concept. But with only components, excessive property passing can occur through many layers of component hierarchies in order to get a leaf component to know about data and functions that exist in an ancestor component. React's context addresses this by skipping all the intermediate steps, just like a service in Ember. So next, we'll need to create a state management system for our context. This could be a class or Redux or anything else. Here, I'm using a recommended way of managing more complex component-level state by using a Redux-like technique powered by React's useReducer hook. Yeah, hooks are new and super cool. So here, we're creating a provider component, In React, there's no dependency injection, so this is what provides the context or state to the rest of the app. The last requirement is that we wrap the provider around the entire app. Without this, the shared state that the context provides will be unable to be accessed. Finally, we can now use this context in our components. This pattern, while it may look like a lot, can lead to very declarative-looking applications. This is what a real-world usage of these context providers looks like. This is an old iteration of a project at my work, though it doesn't look too much different today. At the top level, you wrap the most important dependencies, and in many React apps, there is hopefully a single place where you can go and look to see what services, or contexts in this case, you can grab from within your components. Such as in this application component. And here is what it looks like rendered. Note that this is in the React developer tools, not the DOM. The context providers do not add to the DOM, which is very much appreciated. The green is user or npm package space, red is React, and gray is the DOM. You can see some gray down at the bottom right there. In all of the screenshot, this is just the beginning of the wrapper around the active route, which isn't even shown as it's still a couple layers deeper. So that was just a taste of one of the major differences between the two ecosystems. Let's zoom out a bit real quick to app creation. This part may matter more for bigger companies or consultancies and hobbyists rather than product people, depending on size. But it's very important, and especially to me. App creation is loosely related to the patterns used in a project, but the tooling that empowers the management of a project varies greatly between React and Ember, and that greatly affects the consistency of React apps. So in Ember, we have this one-liner, but you might be more familiar with this, globally installed Ember CLI. And after running yarn start, you're up and running. Cool. To sum up, that is core to Ember. It's never going to fall behind. The Ember CLI is required for building Ember apps, and the tests it generates are against a real browser. So in React, we primarily have two options. For those that may not know, Webpack is an asset bundler that is very configuration heavy and is the opposite of the very idea of zero config setup. Create React App, on the other hand, is a tool for abstracting away the initial configuration of React-based single-page app. It uses Webpack under the hood and is a zero config setup, just like Ember New. Neither option provides testing out of the box. Webpack is not easy, but to me, it seems like it is the most used in production apps. It provides the most flexibility and enables you to build out something like you'd expect from Ember CLI's build command, like maybe asset fingerprinting. Create React App is a decent set of defaults, though it's gradually getting more and more, all without enforcing conventions. If you want, there is a way to eject Create React App, which just means that it'll leave behind all of its innards so that you can configure Webpack to your heart's content. And it's got a one-liner, just like with Ember CLI. And this is all you ever see, given you don't accidentally cause an error. But errors have syntax highlighting, which is very cool. And Ember's errors are just red. So both Create React App and Webpack have syntax highlighted error pages or screens. It makes digesting errors a bit easier and makes me feel better about myself. All right, so moving on to components. These are the easiest to compare because they're the most parallels. They're what we spend most of our time composing, creating UI patterns. In general, components are our playground. So for a little demo, okay. So these are two very identical apps. Ignore the top bar, but one is React, one is Ember. The one on the right tab is React. They both receive a prop at the top, and they have a timer going on, elapsed seconds and minutes, and that minutes is a computed property. And there's that button that increments the document title, and you can clear the time. So not much to it. So in these two code samples, on the left is React and on the right is Ember. Both of these components are more or less laid out the same. At the top is where we set up state, seconds and count, and then we defined a derived property, minutes, and then both components set up some template actions. On the left at the bottom, there are a couple of effects, one for updating the elapsed time and the other for updating the document title. These are not present on the right in Ember because they are in the template. On the right are a couple of custom element modifiers. So these element modifiers are a new feature to Ember, and they kind of correlate closely to some usage with React's useEffect. Aside from these, both of these templates are equivalent. There's just some subtle syntax differences between the angle bracket syntax and the curlies. So in React, remember that use tick call from one of the effects? I don't know if you got a chance to read it, but it's right here at the bottom left, use tick increment seconds. And this is all that's involved with it. This will be invoked on every render, so it's important that we utilize useEffect's memoization along with useRef so that all of our function calls use the correct references to our callbacks. In Ember, there's a lot less we need to worry about thanks to this newish add-on that builds on custom element modifiers, Ember functional modifiers. So custom element modifiers are, again, by far my favorite feature of the stuff that's in Ember today. And thanks to Ember's change tracking system, this is a lot simpler. This useEffect will only be updated if the arguments to it change. So rather than re-rendering as the entire component that consumes this modifier changes, the modifier only updates when it needs to. This is actually a huge difference between React and Ember's component models overall. Ember's change tracking system tries to optimize component updates so that only what is changed will cause dependent parts of the template to re-render, whereas React will re-render the entire template every change. Now, React has a virtual DOM which does some diffing, but that's not important right now. So for the document title changing, both of these, React top and Ember on the bottom, are comparatively simple. The main difference here is that React requires that the dependencies be explicitly called out for cache busting purposes, or else an update will not happen. So let's look at some types of components. A presentational component only displays or formats data. They do not have state, they do not make requests, they don't cause side effects within the app without being passed a function to do so. These are somewhat straightforward. They render what you give them. This example demonstrates the data down part of data down actions up. On the left is React, and on the right is Ember. Contextual components apply markup or surrounding behavior to a content. This is an example of what a card might look like if there were a material UI style framework that implements cards this way. In general, UI integration framework libraries use a lot of contextual components. On the left is React, and on the right is Ember. However, React projects don't really use this pattern. React will either assign subcomponents as static properties on the main export, or they'll forgo the correlation entirely and the export as different top-level components. While this makes importing and general reuse easier, it also makes using consistent nested components much more difficult. With contextual components in Ember, you have very strong suggestions as what components you want to be nested. Container or renderless components provide functionality to the wrapping content without adding any markup to the DOM. Sometimes these may be higher order components, though in React, higher order components mean something a little more specific. This is an example of how one might manage state of their modals throughout their app. On the left is React, and on the right is Ember. The actual state management of knowing which is where, open or closed, isn't important here. But both model state components collect state, and functions are yielded back to the invoking template. A higher order component is a renderless function that takes a component as its only argument. It must return a new component that augments the past component, giving it additional state or behavior. The higher order component pattern doesn't really exist in Ember, at least in the same way it does in React, as we can't invoke components as functions. But the goal of higher order components can be better achieved through container components in Ember. Here is nearly the same React example from the container slide, but as a higher order component. Up at the top, first capture the name of our modal, just like in the previous slide, then return a function that receives a component that then returns a component. This new component may take some additional props and pass those along to the wrapped component, while also passing along the same modal state properties and actions as before. All right, so state management. This is kind of the next level up from components. This is how you manage state from within, around, and between your components. So this is all to answer the question, where does our business logic go? There are a number of places where it can go, but it kind of depends on the situation and what your goals are. We've seen local state. That was the example with the set interval timer and the document title change. We've seen context provider and consumer, and we've seen services. That was the first example with the to-do MVC app. So let's take a look at Redux. If you're not familiar with Redux, it is a very common tool in the React community for managing app-level immutable state. That state could be things like the URL, what data is displayed, errors on forms, anything. Redux works with anything, as it's just JavaScript. So you can use it in Ember, React, Vue, Angular, whatever. Anything can use the patterns Redux provides. It has large benefits if you have multiple UIs. So if you want to share all UI, state, and logic, Redux can represent a headless version of your app. So with data down, actions up, this technique is very prominent in Ember, and it is the one-way data flow. It is not unique to Ember, though, as it is present in nearly every ecosystem and is very prominent in Redux's best practices. But some people have taken this too far, and it may result in prop drilling, where you pass the same props through many layers. This can be present in any single page app and is a maintenance nightmare. But going back to Redux as applied with our component patterns, at the top here, we have a presentation, in the middle, a container component, and at the bottom, the composition of both the presentation and the container together. So, concurrency. Let's take a look at this. So this is an async-aware button in that it doesn't trigger an action multiple times before the executions are complete. As you can see, play. There is an indicator that there is something running, and the last click coordinates indicate that I, in fact, cannot click the button multiple times. Hope you saw that. All right. So this is what we want the component to look like. We read in all the different prop states, the click handler, etc. So let's take a look at what it takes to implement the concurrency handling behind this component. We know that we need to hook up the component to Redux because we want to use sagas. And sagas are the go-to concurrency solution in React apps. So given the property names from the component on the previous slide, we can make some educated guesses at how we want to read and send data to or from our Redux store. And here's the implementation of the Redux reducer and the sagas that manage the concurrency via generator functions. So this might be too tiny to read. It's a lot of code. But this is all the minimally required code for defining async behavior where we have a start, running, and finish state. At the top, just under the imports, we define our Redux actions. There's an action creator. And the middle section is the reducer for the button. And below that are the sagas, which actually manage the change of state during the async lifecycle flow. This is a lot and tends to be duplicated for every async or concurrent task. So let's take a look at how the same thing is canonically done in Ember. Using Ember concurrency, we can use generator functions, just like in Redux Saga, though here, hopefully a little easier to read, except that we now have a task which encapsulates all of the started, pending, and finished state that really every concurrent task is going to need. And the template here is identical to the React version, except that we're accessing properties directly on an Ember concurrency task rather than accessing from the Redux store. So next, authentication. Given all that, let's take a look at what differences we could have here between the two ecosystems. If you don't know about Auth0, it's a very popular authentication as a service. They handle auth-related emails, password, recovery, OAuth, bunch of stuff. Highly recommended. And for this demo, I didn't record it because there's email involved and that gets weird. So if we could all just pretend that these screenshots are a demo, that'd be great. So maybe we want a passwordless authentication. Auth0 provides that. So let's pretend we're clicking that login without a password button. And then the Auth0 default modal appears, and we can type in an email. The Auth0 modal gives us some instructions, which we then go check our email, click the link that's in the email, and then, wha-bam, we're then logged in without having to use a password. So let's take a look at what integrating this looks like in React. This code is mostly from a project I'm working on at work. The far left is supporting integration with Auth0's login modal and JWT validation and checking. The next column is the supporting React component that manages the setup and teardown of the Auth0 modal instance, as well as adding callbacks for when authentication succeeds. And in the last column, the lightweight backing contexts or provider that will allow you to check for the authentication status of the current user. This is still not all the code needed to implement the behavior from the screenshot demo. So what's this look like in Ember? Well, in Ember, we have Ember Simple Auth, which is amazing, and Ember's conventions and service-oriented architecture allows for some really great abstractions to common problems. With Ember Simple Auth, the front-end authentication is somewhat abstracted away. So this uses an additional library, Ember Simple Auth Auth0, but that's it. We just create a couple actions, a button, a before model hook for greeting us when we log in. That's pretty nice. That's it. All right, so testing. Let's say we want to test our authentication. For the upcoming example, I'm not going to be using the Ember Simple Auth tools because it provides some testing tools that make authenticating and de-authenticating a little too easy in tests, and we just can't have that. So because Ember has a dependency injection system, we can, at any time in our tests, access anything from the dependency injection container. Here are a couple helpers that I use in my EmberClear app. And with just those two test helpers, we can create a very concise and meaningful test without really having to know much about dependency injection or where things are coming from. We just call them by name. Here's another helper that I use regularly, stub service. Can look at that later. It allows me to declaratively stub whatever service I want. And because Ember is a component service framework, this is very powerful in that it enables me to be productive in my testing. So we already know that React's context providers and consumers are most similar to Ember services. The style of testing becomes a fair bit more complicated. There are a few techniques that you can use to achieve similar behavior at the test level. You can rewrite your application level component for each test scenario that needs a different mock. If you remember all the way back to that screenshot from my work that had all that nesting, I mean like a different version of those. Yes, you could parameterize all of those mock usings for your provider contexts, but doing that for each provider bloats your test harness. And it has very low ergonomics. Something I've seen in both React and even Node backends is that hijacking import or require statements so that you can swap out entire modules at runtime is pretty popular. It feels brittle and a little hacky, as we're kind of undermining a core feature of the language. So it's totally possible for other libraries to be doing the exact same thing. So hijacking a hijack can get kind of messy. But this is a primary motivator behind the dependency injection system. And not just in Ember, but in general too. So if you have tried ASP.NET, it has a great dependency injection system. You should try it out. The easiest thing to do in a React app is to abstract everything. Like maybe you want to pull out all the state from your providers and context into the Redux store, so Redux ends up wrapping your entire app. It's very easy to just pass one thing to your test harness, that one thing being the Redux state, and then that state then propagates to the rest of your providers. But there are trade-offs with that too, which don't have time for. So, routing. Ember comes with its own router. And the Ember CLI supports generating routes and configuring them for us. The generate route command inserts the route path definition into the statically defined router. And then, via conventions, not only does it place routes at appropriate locations, but also adds a starter test. React doesn't come with a router. So the official tooling of React, which is mostly just create React app, doesn't come with any generators. However, most people use a third-party library called React Router. Most people are going to do two things. They are going to create their new route file and modify the reference to their route in their top-level component here in root.jsx. And React has no way of enforcing conventions. So it's really hard, even on small teams, to remain consistent between all your routes as your app grows. Speaking from experience here, I've been a one-man team for a little bit, and I contradict myself way more often than I would like to. So this is just the contents of the two files created on the previous slide. React is just components, and React Router uses dynamic routing. So every route is a different component hierarchy that is conditionally rendered based on the URL. Compared to a generator command, this is a lot to type. However, the dynamic nature of this routing can make drag and drop refactoring much easier than with statically defined routing. So if you were to implement a file structure similar to the forever rumored module unification, it makes refactoring your React apps super easy, because all the route definitions come with it. So using APIs and getting data from a remote source, Ember's routes are not components. They have lifecycle hooks for before, during, and after you've gotten your data. You can fetch a person from the Star Wars API, and our route template will wait to render until the model hook has resolved. And by default, we don't need to worry about loading states because we can just start building and not worry about timing errors. So in React, there are no model hooks because they don't need to be there. The function's control flow and use effect hook will handle however many lifecycle hooks you want. Anything async, though, may have issues with component unmount if the state tries to update without a component existing to update the state on. This is originally where Ember Concurrency stepped in to solve all the concurrency problems we didn't know we had, until we all learned that we all have them, such as in this scenario. So maybe you navigate to this route and quick change your mind and go elsewhere before the request finishes. First, I commend you on your click speed and accuracy, but you'll get an exception because the component doesn't exist. So you can't set the model on something that isn't there. The React ecosystem also has lots of add-ons. This one, use a boardable fetch, provides a pattern for dealing with this data loading and unmounting problem. It may look more verbose, but it provides a clear pattern for safely making any API call. And there may be other ways to do this, but there is no canonical way of fetching data in React. In Ember, Let's say we want to use a route, or we don't want to use a route, and we want to load data from a component. Maybe we want to eagerly render a UI to have the appearance of rendering quickly. Ember Concurrency provides a wonderful abstraction for dealing with those asynchronous behaviors without having to worry about unmounting race conditions. So relational data is everywhere. Let's take a look at how you'd manage that in your average React application. There's a good number of libraries to try it out. I haven't personally seen any of these in the wild, aside from GraphQL. Apollo's GraphQL client library for React is very popular. I highly recommend trying it out if you want to try out GraphQL. For REST APIs, though, most React projects I've found are using a custom integration with Fetch and Redux and Sagas for every request, and it just seems like a lot of work. Using Redux, we can build our own record store, hopefully index all the records by IDs, look up those records and their relationships through some helper functions, filter that data down. Basically creating our own ORM. Ember Data already does this for us. If we're not looking closely, we can just pass over this file like, oh, it doesn't do anything. But no, it does a lot. Super cool. This pattern, where you have a translation layer consisting of adapters and serializers, is kind of overlooked by a lot of people, I've noticed, at least in React. It's maybe in part due to how easy it is to just handle requests without any abstraction. Or, a lot of people also use GraphQL, and none of this matters. But OK, so query params. React with React Router has query params down. They're super simple. You can get them out of the location object, parse them, go to town. Ember. This example is taken from the Ember guides. They have many more features and capabilities, but it's not as straightforward as React. You can configure what different query params affect the model hook, whether or not they cause refreshes, replace instead of push the route state, system defaults, etc. In React, any change to the URL will cause a re-render of the active route tree. You also will need to figure out a way to set the URL yourself, but I don't know of any React projects that do that. But on the Ember side, there's a restriction on what query params you can use in your links based on what is explicitly defined in the controller. However, something I've been working on. Yep. This is a little proof of concept thing that I did, and it's not yet bulletproof, and it kind of only works with the Canary version of Ember. So I'm sure that everyone agrees query param handling needs an update. But I love the fact that Ember provides enough APIs and tools for me to create something this cool. Well, I think it's cool anyway. But yeah, thanks. That's all I got.